Hello and welcome again to my channel. So, why are we here today? As you can see in the screen, I have opened the lead code number 45, which is marked medium jump game 2. Today, we are going to solve this problem. Let's understand the problem first. So, let's just go here. So, what does the question state? The question states that we are to start from this index, that means index 0. And what we can do from there is we can jump. I can jump from here to here, or I can jump from here to here. Why? Because the position is 2. The value of the position is 2. That means I can jump a distance of 1 unit, or I can jump a distance of 2 unit. If I were here in this index, the value of this index is 3. That means I can either jump here or here or here in one jump, right? If I was here, I can jump this way only once, and similarly only once. The goal or the aim of the question is to minimize the jump to travel from here to here, right? What we can do, we can jump here once, then again, then again, then again, and we can reach the end index. How many jump did we take? 1 2 3 4, and actually 4 jump. Yeah, 1 2 3 and 4. But we need to minimize it. How do you minimize it? Say I jump once here, so that means that is one jump. Then from here I jump only once directly to the end index because the value is 3. So that means 1 plus 1 we get 2. So the answer for this question is 2. How will we write the code? We'll use recursion and memoization. So first let's start with recursion. What do? We'll start from here. So in the recursion function, we'll send this array and also a 0. That means we'll start from the 0th index, right? Now when I'm standing at the 0th index, when I'm standing here, what option do I have? I have two options. I can either jump 1 unit and reach index number 2, or I can jump index number 1, sorry, or I can jump 2 units and reach index number 2. So that means I have two options. The first one is I can jump 1 unit, or I can jump 2 units, right? Similarly, uh, after reaching the first index, here I am in the first index. Since I have taken one jump, right? In the first index I have the option of making 3 kinds of jump, like 1 unit, 2 units and 3 units. So here I will have 3 options, right? What are those? Jumping 1 unit, or jumping 2 units, or jumping 3 units. Since the value is 3, we can maximum jump to 3 units, right? So if you see a pattern here, this is kind of like a loop, right? We are starting from 1 and we are going to the maximum, which is the value of that particular index. In this case we were in index 0, maximum value is 2, so we'll run a loop from 1 to 2. Similarly, in index 1, the maximum value is 3, so we'll run a loop from 1 to 3, right? If the value of index is simply 1, we have only one option of making only one jump, right? Let's say in this case we choose to make the third jump, right? 3 units jump, and we'll reach the end index. So here we reach the 4th index, right? 0 1 2 3 4. The last index is 4, right? We have reached the fourth index. So what to do now? We have reached our goal, right? We have reached our goal. So we since we have reached our goal, we should not do anything further, and we'll return a 0, right? So from here we'll return a 0 here. We'll return a 0. Now in this case, in this particular state, what should we do? Like, we made one jump, right? Either we made this jump or the second jump or the third jump. In any of the case, we are making only one jump. So what we have to do here? We have to do 1 plus. That means whatever we get from this recursion call, whatever we get from this recursion call, so basically whatever is returned from this recursion call, we'll just add 1 to it, right? Because in this particular step we only made one jump, and since in making the third jump we reach the goal, will return a 0. That means we are not making any further jumps down the line, right? So we'll add 1 plus 0 and we'll return again from here. We'll return 1, since 1 plus 0 is 1. And again in this state we do 1 plus, because in this particular call also we are doing a single jump, either this one or that one, and then 1 plus 1 will return 2, which is the final answer of this question for this particular input, right? So let's code it out. Here I'm going to write a function called solve. This will be a recursion function. We'll pass the nums here and also the current index we are on, and we'll return an int. So the condition for breaking the recursion base condition will be if idx has reached the last index, which is length of nums minus 1, then we'll return a 0, right? That is the base condition. But there can be one more base condition, which is, if you see here, let's suppose that there's another input which is like 2, or let's say 1 2 3 4 5, right? So now if we reach this index, we have 4 options, right? We can make 4 jumps at this point, which are 1 2 3 and 4. So this will be 2. So at this particular index, we have 4 options. We can jump, we can either make a jump of distance 1 or 2 or 3 or 4. But if you look closely, you'll find that if we are in this particular index and we make a jump of 2, we'll get out of the bound, right? We'll go out of the bound of the array. Similarly, with a 3 jump, again we are going out of bound. With 4 jump, definitely we are going out of bound. So we need a condition to cover that condition as well, and that condition will be if idx is greater than length of nums, or greater than equal to length of nums, then we'll return int 1e9. Now what is this? This is a very large number, and why I'm selecting this I'll tell you in a bit, right? So let's start with the for loop. As I said, in every step we'll write a for loop that will go from 1 to the maximum value possible, which is the value of that particular index. So the for I equal to 1, it will go till I less than equal to nums of idx and I plus plus, right? Now for every index we are making a jump, right, which is jump equal to 1 plus, that means we are making a particular jump, and then we'll call the recursion function. That means I'm saying to the code that I have jumped once here with a distance of I. Now bring me the further jumps that I made down the line to reach the last index. So this means we'll say nums and idx plus 1. That means we made one jump of one distance. So or actually here it will be, oh no, it's correct. So I made a jump of 1 unit or whatever unit, let's say it's 2. I made a jump of 2, so idx plus 2, I'll reach 2 index down the line in the array, and I made in total 1 jump. So 1 plus whatever jumps we'll get from this function, right? Now we'll have a variable here called min jumps, which will be 1e9. It should be a large number, so let's take it 1e9, and it will be an int, right? Now for every step we have to check min jumps equal to minimum of min jumps and the current answer that we have received, because for every index we are trying to get the minimum number of jumps, right? So let's say here, as you can see, we are making a total of 3 jumps, right? And out of these 3 jumps I want the minimum answer possible, which is this one. It's returning a 0 because we have reached the final index in just one jump, right? But these two cases will return something greater than 0. Why? Because if in this particular index, that means in index 1, this one, if you make 2 jump, 1 2 will reach this index, and we have to make another jump again to reach the last index. So this particular route will return us a 2, that means it's saying that we have to make 2 more jumps if we go down this route. Similarly, this route will provide another answer, but out of these 3 answers the smallest will be 0 because we have already reached the last index with just a single jump, right? So that's why in all the 3 cases, out of all the 3 cases, we want the minimum answer possible. That's why we are doing this. Now what about this case? When we reach out of index, we are returning what? We are returning 1e9, which is a very large number, right? So this returns 1e9 and we add 1 to it, which is whatever, but it's a very large number, right? But since we are doing a minimum here, minimum function, it will take only the minimum answer. So this answer, even if we return 1e9, it will not be considered, which is correct, right? We don't want any answer to be from out of bound because we don't want to go there. So that means this logic is correct. That's why we have taken that's why we are returning if you are reaching out of bound a very large number, so that we don't return that in here. Finally we'll do return min jumps. So return solve with nums, and initially we are starting from 0th index. Let's see if this runs or not. Okay, we are getting a wrong answer. Why are we getting a wrong answer? 4. Okay, I've made a mistake here, which is it should not be idx plus 1, it should be idx plus I, basically whatever the distance we are jumping, right? So I missed that. Here it will be 1 because we are making one jump, but the distance of the jump will be idx plus I, right? Let's run this now, and it is working, but this will give a time limit exceeding error because we have not memoized it. So let's do memoization also. So we'll say memo equal to make array of int with a length of similar to length of nums, right? Now for I, range memo -1, and we'll pass this down, and memo here will be array of int. Now if memo of idx equal to not equal to -1, that means we already have the answer, we don't need to do the recursion in the for loop, so we'll just return memo of idx. And finally memo of this particular answer for this block or this recursion call will be memo of idx equal to min jumps, and we'll have to pass memo here as well. Let's see if this works. Okay, let's submit, and it is working. So this is the full code. Thank you for watching.